So in creating this table for tangent, I'll give you the x values. Make sure you guys are in radians. And the purpose of this is I want you guys to get a general idea of what tangent looks like, what its shape looks like. So let me give you all the x values. So there's all of them. And after you find an answer to each of those, you guys will have decimals. Just go to the third decimal place. After you have all those, we'll graph them. We'll graph those points. And around the 3 decimal places. So I know you guys used your calculators when you did this, and so that means you didn't get exact answers, but you guys did round to the nearest third decimal like I asked. Can somebody volunteer to read me the numbers? Mauricio wants to do it.
I didn't get decimals.
You didn't get decimals? Oh, so you used the table or the unit circle? Good man. Did anybody else do decimals? All right, go ahead, Logan. Read them.
0.577.
Now what?
1.
1? And then?
1.732.
And then?
No, 1.732.
And then?
I got no answer.
No answer for pi over 2? Okay. Next? 2 pi over 3?
Negative 1.732.
That meant 1.732. Then?
Negative 1.
And then?
No, negative 1.
Oh, that's not negative 1. And then?
Negative 0.577.
Okay, can you go faster?
0. Negative 0.5. Wait, no, sorry, no. Positive 0.577.
Oh, what's that pattern? Look at that pattern. Is this next one 1?
Oh, right, because
Yes, wait, is that 1 or negative?
That's 1. What's next?
1.732.
And then? Nothing?
Yeah.
Okay, and then?
Negative 1.732.
And then?
Negative 1.
There you go. So you guys see what our graphs look like? You guys found all those. Did you guys... Alright, so if you use a unit circle, what did you get for for this guy right here? What is that? What is 4 pi over 3 equal to? On your unit circle.
Root 3.
That one's root 3. And is this one right here rad 3 over 3
Yeah.
for that one? Okay, so if you're using your unit circle to find the answer, that's what you would get. If you plug into your calculator right now, the square root of 3, you'll see that you get 1.732. Yeah? You see? Try it. Did you try it? It's kind of neat. Let's go ahead and throw, since we're on a graphing utility right here, let's throw a tangent in here and see what it looks like. T-A-N-X. Boom. We hit all of our points. Look at that. Look at that. So fancy schmancy. Now, tell me guys, why did pi over 2 not work? Why does pi over 2 not work? Let's see, let's look at our unit circle, right? Pi over 2 is right here. We know that tangent of x equals sine of x divided by cosine of x. What is cosine at pi over 2? What's the x value at pi over 2? Oh, you guys are dead out there. Well, it's 0. It's 0. And so you get 1 divided by 0. And what is 1 divided by 0? Undefined, which is why right here at pi over 2, you don't see any of the line. Like there's an asymptote right there. And that is also true for 3 pi over 2. So, what is the period of tangent? When does tangent start repeating itself? How far? Let's see, going from here to here. What is that distance? That is pi. And you can also see it if I drag this over a little bit. If I go from negative pi over 2 to pi over 2, what is the distance between those two? Going from negative pi over 2 to pi over 2. Is that also pi?
Yeah.
Yes. And so our normal period for tangent is pi. We have asymptotes at negative pi over 2 and pi over 2, so on and so forth. This is what tangent looks like.